Here we are on the steam launch KDN-2, and the inspiration from this project came from the fact that we usually take a lunchtime cruise every day, and I realized we were did a half a dozen loops quite often, and I thought, well, why should we have to steer all those different times? So I decided I wanted to build an autonomous system. They'd have two features. They would either follow a compass course or it would follow a route set with GPS waypoints. So that was the inspiration for the whole thing. This is a typical loop we might take, and this is another one. Here is the main controller for the autonomous steam launch. We have a Arduino Uno. This is a GPS shield that just stacks on top of it. That's a GPS unit. That goes off to the external GPS antenna. This is a motor driver shield which drives the tiller servo motor as well as a hobby type servo for blowing the whistle. And this is a remote control and the controller. And here is the completed box. Everything just fit inside and ready to go. And that's the remote as you saw earlier. Also, this is a high torque hobby servo which I'll use to blow the whistle. And here's the main controller. It's all in the boat. This is my inertial reference unit. It includes a magnetometer which measures the Earth's magnetic field similar to a compass, but it does in 3 axes. It also has an accelerometer, and with that you can measure the Earth's gravitational field as well as linear acceleration, but I don't use that in the steamboat obviously. But then you can calculate the roll and pitch and compensate the compass heading, and that way you end up with a dual gimbal electronic compass. And it also includes a gyro, so you get heading rate. You get degrees per second you're turning at, which you use in your control system. This is my homemade tiller servo motor. It has a small gear motor I got from McMaster Car. It also has a feedback pot right there. So which is driven by this link, and that way I know where it's located. And I put limit switches also on it, and this is the link which drives the tiller. And here's the servo motor installed with the link to the tiller. This is the human interface with the autonomous system. It shows here that we have a desired heading of 150. And these PID are constants for the controller. P means it's you move the tiller based on what is happening now. It's proportional term. So I have found that if I'm off course 5 degrees, I'm best off moving the tiller by 5 degrees. The I term is the integral term, and that has to do on what's happened in the past. How far off you were off course and how long you were off course affects that. And I use 0 for that constant. I don't find that I need it. The differential term, the D, has to do with what's going to happen in the future. And and I find 2 works for me. And what that is if you are 10 degrees off course, but if you are closing in at 2 degrees per second, well, you're going to be there pretty soon, so you better start doing something about it. So this would reduce the tiller angle by 4 degrees. So this would make, if I was 10 degrees off course, this would make the tiller 10 degrees. But if I was going at 2 degrees per second towards the course I wanted, this would reduce it to 6. And that just makes it more stable. And you can change these constants from using these very buttons here. But I find that these work out pretty well, but I'll probably continue to experiment with them. This is in compass mode. Another feature is if you want to change heading. Right now we're desired heading of 107. You just push this left button and it'll reduce it 10 degrees each time. So now we've gone to 97 and 87, and so it changes course. If you push this button right there, you will go to GPS mode. So now waypoint 1 is a distance of 408 feet, 4044, it's going to it, and it's at a desired heading of 172 degrees. And it's the same PID constant. So I will show you what happens when we get closer. It doesn't switch to the next waypoint until you get to within 75 feet of the waypoint. Okay, so now we're 149 feet, 128, 124, closing in on waypoint 1, 98, 4, 81, and there we went. We switched to waypoint 2, right here, waypoint 2. The distance is 430 feet, and we're actually going away because I have to make the turn here, and the desired heading is 340 degrees. So you can see we are turning, going on to the next waypoint. And we're going around. So now we have 390 feet to go to the next waypoint. So this has been a fun project, both software and hardware-wise. It's got almost 500 lines of code, every one of which has to be perfect, and it's about at the extreme limit of my my code writing ability and patience. But one of the things I didn't appreciate is that, you know, I have a lot of neighbors and friends around the lake, and sometimes I get busy doing other projects and I just don't have time to go steaming. Well, they'd be very disappointed not to see me every day and to whistle them up. So with this system, what I can do is just load the boiler up and send her off on a loop by herself. She'll blow the whistle at the right time, and I just listen for the dying whistle when she gets back home, and I go out and gather it in, and everybody's happy.